Dear students, we have seen in our previous classes how to group data from one variable of a population into a frequency distribution. If you have data on a particular variable, say mark of the students, height of the students, etc., you know how to group this data by using classes or by using single groups, etc., and also how to construct frequency distribution, absolute, relative and percentage frequency distributions. And the data so collected and plotted from just one population is an example of a univariate data. Univariate data. But there are many situations in which we may have to group and analyze data involving two or more populations. There are many situations in which we may have to collect, group and analyze data using two or more populations. For example, if you want to study a correlation between two variables or the dependence of one variable on another variables, as in the regression analysis, we may have to group and analyze data from two or more populations. Now, data from two variables is an example of bivariate data. So, univariate, bivariate, and if more than two variables are involved, you have multivariate. Univariate, bivariate, multivariate data. And the frequency distribution from a bivariate data is known as contingency table or a two-way table. Data from bivariate data is known as contingency table or a two-way table. As an example of a contingency table, consider a two-way classification like this. We consider two variables. One is the age of faculty, the other one is the rank of the faculty. Now, the rank is full professor, associate professor, assistant professor, instructor. For age under 30, 39, 40, 49, 50, 59, 60 and above. 60 and above. Two, 52, 156, 145, 75, 3, 170, 125, 68, 15, 57, 163, 61, 36, 3, 6, 17, 6, 4, 0, 68, 402, 348, 253, 1164. Sorry. Now, adding this way, you have 430, 381, 320, 33, total 1164. This is an example of a contingency table. Full professor under 30, 2, assistant professor between 50, 59, 36 and like. From the contingency table, we can calculate joint probabilities and also marginal probabilities. Let us see how. Now the question is, let the event A1 is, let the event A1 is, the faculty member is below 30. Faculty member is below 30. Then the probability of A1 is equal to 68 by 1164. 68 by 1164, it is 0.058. 0.058. Let the event is, the faculty member is an associate professor. Then probability of A2 is equal to associate professor 381 by 1164 is equal to 0.3276. These are joint probabilities, 0.058, 0.327, etc. Now, these probabilities, a total of probabilities, these are not joint probabilities, these are, remember this, under 30, so between 30, 39, etc. So 0.05, 0.327, etc. A total of 8 probabilities. Sorry, 8. There is one more here. That is, the value is, sorry, the value here is 93. A total of 9 probabilities. And these probabilities are known as marginal probabilities. Total of 9 probabilities. These probabilities are known as marginal probabilities because they correspond to events represented in the margin of the contingency table. They represent events in the margin of the contingency table. So these probabilities are known as marginal probabilities. We can also find joint probabilities. For example, what is the joint probability? Probability that for convenience I give R1, R2, R3, R4. Then these are A1, A2, A3, A4, A5. Now, what is the joint probability of A1, A1, A1 and R2, or a probability that A1 intersection R2, A1 intersection R2. This probability is R2 A1, that is 3 by, so it is equal to 3 by 1164 is equal to a very small value 0.003. So in this way you can calculate all the joint probabilities 0.002, 0.003, 0.049. That is, you divide each entry with the total number of observations, you will get the joint probabilities. Say A1 R1, probability of A1 R2, probability of A1 R3, etc. etc. These are the joint. If you convert the contingency table into probabilities, you will get what is known as a table of joint and marginal probabilities. Table of joint and marginal probabilities. And remember this, contingency tables are important and extensively used in the context of inferential statistics to study the association between variables. To study the association between variables, we calculate both the conditional probabilities and also joint probabilities. That is contingency table, joint and marginal probabilities.